welcome back, AP Calc. We are going to hit a couple of examples of using u-substitution with integration when we have our upper and our lower limits as well. So I've written this question up here on the board. It's an example problem that if you look closely, you might find someplace in some of your work. And what we're going to do is decide what we want our u-substitution to be, or if it's even applicable here in this case. So I'm looking at this function. I have a limit of the integral from pi over 4 to pi over 2, 3 cosine 2x, sine 2x with respect to x. And I'm thinking, I've done a couple of these cosine sine or sine cosine things. I can go either way with this one. I could let my u be the cosine function because the derivative of cosine is negative sine of my angle, then times the chain rule with the derivative of the angle. Or I could let my u be sine of 2x, in which case the derivative of sine would be cosine, and that way I don't have any negative sign to play with. So I think I'm going to go ahead that way. I'm going to stay positive as much as possible. So I'm choosing my u in such a way that when I take the derivative of my u, it ends up being positive, and I don't have to play with a negative sign. So again, u is equal to the sine of 2x, because du will therefore be the cosine of 2x. Remember, your angle never changes. And then you chase this with the derivative of your angle, which is a 2, and with respect to x. So I'm going to come over here and I'm going to look at this function. And I might just want to rearrange things a little bit if I want to take my time and do so. I don't need this 3 sitting here, so I want to pull that to the outside. So I want to do this. We'll keep it pi over 4 and pi over 2 for a moment because I'm going to stay in terms of x's. I'm going to put sine of 2x first, and then I'm going to put cosine of 2x dx. Just because the cosine and the dx, they group together right here, so that'll be an easy substitution when I do this. Now this 2 seems to be in my way a little bit. I want to get rid of this one because my u is sine of 2x. There's my u. And cosine 2x dx is the only stuff I have left over here. Over here I have cosine 2x times 2 dx. So we're going to get rid of that 2. We call it 1/2 du is cosine of 2x dx. And this matches perfectly right here. So in place of cosine 2x dx, I want to write something in terms of u. I'm going to put this 1/2 du right here.
Mr. Miles, please report to the main office. Mr. Miles,
all right.
Please report to the main office.
So when I rewrite this all in terms of u, I'm going to end up having the 3 here, my integral symbol. This sine of 2x is u. This cosine of 2x dx is 1/2 du. And notice I'm not putting any numbers here for my lower limit and my upper limit anymore because these are values on the x-axis, and I know they're x coordinates because this function was given in terms of x. So this, my a and my b limitations are x's. They're not u's. I can't record them here as long as I've switched into the u mode. So I'm going to make this pretty. Now I'm going to bring the 1/2 to the outside and call it 3/2. I'm going to leave my integral of u du, and I'm going to come over to the side and I'm going to say, well, in terms of u, what would my lower limit have to be? In terms of u, what would my upper limit have to be? So we're going to be really neat when we write this out. We're going to say when x is, I'll do my lower limit first, pi over 4. When x is pi over 4, u equals what? This needs to be in terms of u. So I go up to where I did my u substitution, and all I have to do is put in x equals pi over 4 into whatever my u value was. So sine of, open parentheses, 2, and here comes my x, which is pi over 4, so I'm just going to say times pi over 4, like that. And then I will evaluate this. 2 times pi over 4 is pi over 2, and the sine of pi over 2, I hope everybody knows, is what? Hopefully, we got the fact that it's a 1. The sine function starts at 0, ends at 0, halfway in the middle, it's also at 0, and I'm talking about from 0 to 2 pi. The sine function goes up and then it goes down. So right here you can see at pi over 2, which is halfway between 0 and pi, the sine function is up at 1. Another way you can determine the sine function is to look at the unit circle. at pi over 2. This value right here is 0, 1, and it is the y-coordinate that represents the sine function, because every single point on your unit circle is the cosine of theta times, or comma, sine of theta. So the first coordinate represents the cosine of the angle you're on, and the second coordinate represents the sine of the angle you're on. Either way, when x is pi over 4, my u is simply a 1. So I'm going to come back to where my limits were, find my pi over 4, it's on the bottom, I'm going to replace that bottom limit with a 1. And then just to wrap things up, we also have to know when x is, my upper limit is what? Pi over 2. U is going to equal, go back to original function again, sine of 2 times my x. And the x is pi over 2. The 2's cancel, and this is just the sine of pi. And the sine of pi, we can look right here, is 0. So u is equal to 0 as long as x is pi over 2. So when I had a pi over 2, which was my upper limit, I'm going to put a 0. And as far as your homework goes, this is where I told you to stop. So this is what I'm going to box as an answer. Okay? However, for the sake of the video, I'm going to go a little bit further. And I am going to take this question and erase all my u-substitution stuff over here, because I can finish this problem totally in terms of u without having to drop back into the x mode, because my limits are now in terms of u. So I'm going to erase what's sitting right here, and I'm just going to finish it up. Although for your homework, you don't have to finish it up. All you had to do is set up your limit, set up your integral, in terms of u, so that it was nice and neat with any coefficients factored to the outside, and so that your integrand was ready to be integrated. All right, so I'm going to take this up here. 3 over 2 times the integral between 1 and 0. And I know that seems like it's backwards. If you feel like flipping it, go ahead, but you got to put your negative sign in. I'm going to just leave it right where it is and let the negatives work themselves out. Of u to u. So this is 3 over 2. Integrate u with respect to u. I'm hoping you get u squared over 2. And we're going to evaluate that from 1 to 0. Sounds strange, I know, but we're just going to keep with it. So this is 3 over 4 u squared, evaluated from 1 to 0. And I like those brackets, don't I? So 3 over 4, top number goes in first, so 0 quantity squared, minus 3 over 4, and then put your 1 in for your lower limit, quantity squared. 0 squared is 0, multiplied by 3/4 is still 0. This gives me 0 minus 3/4. So the answer to the original problem is a negative 3/4. All right? And I never had to turn back in terms of my x's. So this is good. All right? I'm going to put another example up on the board right now, and we're going to start working through the whole entire thing again, and then we'll say this is the end of the video. So let's wipe this out. All right. We'll call this example 2, but again, you look closely through your work and you might just learn something here. So we're going to start with the integral between 0 and 4. 5, I have a 2 root x on the denominator, as well as a 1 minus the square root of x quantity cubed, and I want that integrated with respect to x. That seems like it's just a whole bunch of mess sitting right there. So we have to reorganize it, maybe condense it a little bit, and that's what the u-substitution is for. It's to condense the problem and make it more easily integratable. Okay, so where are we here? I'm looking at some quantity that's being cubed right here, and I'm thinking maybe this is my u. If I were to take this derivative of 1 minus the square root of x, is its derivative somehow a constant multiple of all this other stuff I have left over? And it does turn out to be exactly that. So let's go ahead and just show you what I'm talking about, because I can see this in my mind. I'm not sure if you guys had that yet or not. where we're going to say let u equal the quantity that's being cubed, 1 minus the square root of x. This ends up getting my u. So I'm going to have a u cubed in my denominator, which is no big deal. I can just move that up to the numerator and call it u to the negative 3 when the time comes. All right, now du. The derivative of 1 is 0, okay, minus, and the square root of x over here is the same thing as x to the 1/2. So if I want to take this derivative, all I have to do is bring that exponent down, x to the negative 1/2, because I have to subtract 1 from that exponent. This negative on this exponent is going to bring this x down into the denominator, and the 1/2 represents a square root symbol. So this is the same thing as 1 over, the 2 is on the denominator already, and the root x is going to come down and join it. So this ends up being 1 over 2 root x dx. Now, I don't want to get too crazy with you, but you can just call it negative 1 over 2 root x dx. Which is kind of nice. You see your 2 root x over here, and it's on your denominator? So that's part of your du that you're playing with. Now, because things just get so condensed here, they just seem really messy right now for the meantime, I'm going to rewrite this like I did the last one. So I can get this negative 1 over 2 root x dx sitting to the right. Matter of fact, that negative sign looks like I'm going to make that go away somehow or another, because I don't see a negative sign over here. Well, let's just rewrite this. We're going from 0 to 4. I'm going to stay in terms of x's for a minute. Let's pull that 5 to the outside. Anybody see a 5 over there they want? Probably not, okay? This 5 would be really nice to be just take it to the outside. Looking at 1 over 1 minus the square root of x quantity cubed. And then I would like this 1 over 2 root x dx. So I'm basically just taking these two factors on the denominator, turning them around, and splitting my factors up. This is multiplication between here. So if I put it all together, can you see how the 2 root x would be first, and this would be second, and the 5 I already factored out to the outside, and my dx is just sitting there. It's going to be really nice to do a substitution of my u stuff now. All right, let's get rid of this negative sign right here and call this negative du equals 1 over 2 root x dx. That means all of this is my negative du. This is my u. I should be good to go. Everything is replaced with u's instead of x's, with the exception of my limits. Now let's write this in terms of my u's for a second. So this is u cubed, and it's on the denominator. I'll leave it there momentarily. This is times, and all of this goes together and becomes my negative du. So I'd like the negative to the outside with the 5. I'm going to integrate u to the negative 3 with respect to u. And of course, I need my upper and lower limits to be in terms of u now, not in terms of x. And these are x values. This is integrated from x equals 0 to x equals 4. I know they're x's because, again, I started with a whole bunch of x's here. I need them switched to u's the moment you switch to u's. So let's come over here, and we're going to say when x equals, and start with your lower limit just to always do the same consistent thing. When x equals 0, u equals, and then I go back up and I find my function in terms of u. So 1 minus the square root of x, and x is 0. So 1 minus the square root of 0 means 1 minus 0, which means my u is a 1. So when x is 0, I'm going to replace it with a u value of 1. And then lastly, when x is, what's my upper limit there? 4. U will equal, I go back to where I did my u substitution right here. 1 minus the square root of x. My x is a 4, so I will put the 4 right there. The square root of 4 is 2. So the u value ends up being a negative 1. Then I come up here, put my negative 1 for my upper limit, negative 1 for my upper limit, and I'm going to rewrite this now. And I'm going to do it right there because I don't have room enough underneath here. So I have my u to the negative 3 du, da da da. See this? I can turn this upside down. I can get my negative on the bottom, my positive on the top, get rid of that negative sign right there. So let's do that. Let's turn this around. It just makes it look just a little bit neater, doesn't it? To have a positive 5 and then go from negative 1 to 1 of u to the negative 3 du. This, according to your homework assignment, is as far as you needed to go. You needed to set up an integral in terms of u with all coefficients, all constant multiples just being pulled to the outside, and then get everything ready to integrate. So you would not leave me 1 over u cubed. You'd turn this into u to the negative third because we're going to go ahead and use a power rule on that. That would be the end of your question for your homework. However, like I did on the previous example, I'm going to erase all of this u and x stuff because it really has nothing to do with the rest of my problem anymore. And I'm going to finish this question for you. Alrighty. So 5 times the integral from negative 1 to 1 of u to the negative 3 du. Well, 5, now what is the integral of u to the negative 3? It's u to the, and I have to add 1, let's not forget, negative 3 plus 1 is going to give me a negative 2 over negative 2. Alright, and normally I would say plus c here, but I have a definite integral, so I don't have to. I'm going to go from negative 1 to 1. You can simplify this as much as you want before you substitute in and do your fundamental theorem of calculus. So I will take the negative to the outside and call it negative, and I'll take the 2 to the outside and call it negative 5 halves. I'd like to bring this u to the negative 2 down as 1 over u squared. And I will take this quantity and I will evaluate it from a negative 1 to a 1. So I need 2 sets of brackets. Now, I suppose I could factor the negative 5 halves right to the outside, but I don't want too many parentheses and brackets and things going on. So I'm just going to keep negative 5 halves 1 over u squared, negative 5 halves 1 over u squared. My u is a positive 1 first, negative 1 second. Upper limit goes in first, lower limit goes in second. 1 squared is 1, 1 divided by 1 is 1. This is just negative 5 halves. I'll keep my bracket for just a minute because I don't know what's happening over here. I take a negative 1 and I square it. That's still a positive 1. 1 divided by 1 is still 1. So this is a negative 5 halves. So what is a negative 5 halves plus 5 halves going to give you? And that answer is 0. Big old goose egg. Okay? And hopefully that would make sense. Alright, so I'm looking at this and I'm just wondering, why am I getting a 0? I just want to think about that for a second. U to the negative 3, that's a cubic function. Looks like it's an odd function, and I'm going from negative to positive, so I do think the areas are going to counteract each other. Yeah, I'm going to go on that. I don't know if you followed what I just said to myself, but that answer is good. Okay?